So this topic is bit technical in nature, okay, but this will tell you how actually the aircraft flies or how drone will fly or how drone flies. Okay, so it will give you that concept or principles how actually the flight happens. Okay, so basic principles of flight. Do you have any idea how actually aeroplane flies? Before I proceed, any idea, any thought process? We always have a curiosity like aeroplane, itna bada aeroplane or drone flies and all things. So can you just share your understanding or experience?
Sir, may I?
Yeah, yeah, please go ahead.
Sir, so aerodynamically shaped object with
Okay,
the increasing velocity of air under it
right,
creates a lift, and because of which it can fly.
definitely, definitely. So basically, we'll see how actually the aircraft flies and what are the principles involved. So Nishant, you are more or less right on your aspect. Only it is to be framed properly. Okay, so before that, I will give you some background how actually the lift happens. Okay, how the aeroplane flies aerodynamically. Your aeroplane can fly aerodynamically, whereas your drone doesn't fly aerodynamically, but still drone flies. So how these principles are applicable in the aeroplane as well as in drones. Okay, so let's see now. So what are we going to cover in this? Fundamentals of flights, the aerodynamics, takeoff, flight and landing, and maneuvers, turns and circuit patterns. Okay, how are we going to fly our aeroplane or how are we going to fly our rotorcraft or drone? Okay, so fundamentals of flight will cover these points. Okay, these are definitions: aerofoil, chord line, relative wind, center of pressure, angle of attack, angle of incidence, center of lift, center of gravity, and lastly the Bernoulli principle. Okay. So let's see what is airfoil. Airfoil is a cross-sectional shape of a wing blade of a propeller, rotor, or turbine. So if you see the wing shape, okay, the wing shape, the cross section, if you take, you will see something like this, okay, like this shape. So it will have a bigger shape in front, whereas it will have a curved shape or a short surface at the back. So the bigger surface is called as leading edge, or the front surface is called as leading edge, whereas the back portion is called as trailing edge. Okay, so this is like a wing shape. This is the part of a wing. Okay, so that is called as airfoil section. Remember this definition. An airfoil is a cross-sectional shape of a wing or blade of a propeller, rotor, or turbine. Okay, so if you take a wing of an aeroplane, or even you take the propeller also, or you take a propeller of a turbine also, all if you take the cross section of that, you will see the cross section like this. Okay, so you will have a leading edge which is a bigger in size. Wherever the both surface join, that is called as a tip, or it is called as a trailing edge. Now there is something called as a chord line. Chord line is nothing but a line, straight line intersecting the leading and the trailing edge of the airfoil. So right from the leading edge till the trailing edge, we draw a straight line that is called as chord line. This chord line plays a very important role in lift. Okay, let's see the next. Relative wind. Relative wind is nothing but direction of airflow with respect to the airfoil. So you can see here there is an aeroplane, okay, which is moving over here in front direction. This is a flight path. Okay, so aeroplane will always move in a forward direction or a front direction, forward direction, what we call. And you see the cross sectional of the wing or the thing. With respect to that, with respect to the flight path, your relative wind will be always in a opposite direction. Okay. Now, if you see this motion of your aeroplane or of your wing, the angle measured between the relative wind. See this relative wind over here. Okay, the relative wind over here, and the angle created by the chord line. You extend the chord line from your trailing edge to the leading edge. You take it further up in the sky. There will be angle created with respect to the relative wind. That angle is nothing but called as angle of attack. Okay, so this angle of attack can be changed by the pilot. Okay, he can do changes. whereas angle of incident, now angle of incident is angle between the chord line. Now chord line is with respect to the wing. Okay, the angle between the chord line of the aerofoil and the longitudinal axis of the aircraft. Now, what is longitudinal axis? From the tip or the nose of the aeroplane till the tail of the aeroplane, that straight line is called as longitudinal axis. Okay, if we create an angle, that is called as angle of incident, and this angle cannot be changed by the pilot because these are two fixed. Your longitudinal axis is fixed. This angle of incident can be defined only during the design of your aircraft. Okay, not during anything. Whereas angle of attack can be changed, can be modified with respect to your flight. So as you change your angle of attack, your lift will increase or decrease, but you cannot go beyond required angle of attack. उससे ज़्यादा होगा. There is certain something we call it as for this particular aeroplane, the angle of attack is x degree. If I go beyond x degree, what will happen? Any idea?
You may stall.
Yes, the aeroplane will stall. So if you go beyond the angle of attack, your aeroplane will be completely out of your control and it will fall down like a dead rock. Okay, you will unable to control it bad. But then you will have a question. Like you might have seen a fighter jets, right? The military jets. They also do and they come vertically up and down and here and there. So these aeroplanes are very, very high powered jet engines. Okay, they have more power than anything else and they are smaller in size, so their power overcomes their aerodynamics. Okay, so it can change their direction, flight, everything in a moment by power. Okay, the thrust what it generates, it's a huge jet engine, whereas the same jet engine which is being used in the aeroplane, they are not very high powerful, they are only that much which is minimum required for aeroplane to fly. ओके, अगर वो एंगल चेंज हो जाएगा या if the commercial aeroplane pilot decides to fly a jet, the Boeing or Airbus, like a military airbus, he will not able to fly because he will not able to control it. Okay, it's very difficult since it's a big in size and the engines are not that powerful compared to your military aircrafts. Okay, any questions on relative wind, angle of attack, angle of incidence? This is very important, angle of attack.
So can you please explain the angle of attack again?
So angle of attack, see, assume this is the wing. Okay, assume this is your wing and it is moving on the runway. Okay, now the relative wind will be flowing from this direction. Okay, so it is actually hitting the your airfoil section. It is hitting your chord line. It is hitting your leading edge. So what happens? There is an angle which is being created. Okay, there is an angle created with respect to the chord line. If you extend this chord line furthermore, you will see this angle. Okay, so what will happen? The relative wind is actually hitting your airfoil section. So the air will distribute over the wing as well as below the wing. Okay, over the wing and below the wing. So we'll talk about that more in detail. Just hold for a moment. There is a slide which talks about how the lift is created. As of now, just think about angle of attack. The more angle you created, what will happen? This will become more up. Okay, so it no longer it will try to lift, but it will try to push it backward. For example, if you are driving a car and you take a hand outside of your window, okay, and you are holding the hand parallel to your ground, your palm parallel to the ground, what happens? You will only feel the air, but you slightly shift your hand by angle. What you feel? Your hand will try to go up. Okay, it will try to raise up. But if you give more angle, okay, make it 90 degree, what happens? Your hand no longer goes up, but it goes behind, पीछे चला जाता है, right? So that is the effect of angle of attack. That is what angle of attack you can feel. The more angle of attack you give at certain point, it will not generate a lift, whereas it will generate a drag. That is called as a drag. Okay, and it will tend your aircraft to not lift, but it will tend your aircraft to go down. Okay, it will no longer in a flight condition. Okay, that is angle of attack. Clear?
Yes, yes, yes.
Okay, so now let's see what are the forces affecting on the flight. So there are total four forces on the flight or the aeroplane. There is something called as weight. By default, there is a body, the surface is there, there is a weight. Okay, so the weight will always tend the aeroplane to come down because of gravitational effect on it. Earth is pulling it down. The gravity will always try to pull the aircraft down or towards the center of Earth. Okay, whereas opposite of weight is lift. So we try to give aerodynamically lift to the aeroplane, okay, by the wing section. Now it will not on its own generate the lift, because as it is stationary on the ground, the aeroplane doesn't fly on its own, right? It needs power. Now how that power is generated? Power is generated by the thrust given by the engines. So engine generates the thrust. Your aeroplane runs on the runway. Okay, so it keeps on running at a given point in time. It has enough thrust, and the pilot who actually controls the wing shape. Okay, he creates the angle of attack. That angle of attack is suitable for generating the lift. So the moment you reach enough speed and the thrust, your airplane will glide in the air. So you might have seen when you are flying in an aeroplane, as it is running on the runway, it will run almost for 1 or 2 kilometers. And moment it reaches the V1 point, okay, there is something called as the V1 point on the runway, it will glide. Okay, so that is the point where the aeroplane has to glide in the air. It cannot stop. नहीं तो क्या होएगा? It will hit the wall of the runway. Okay, so it has to glide at particular point. The pilot has to give that much thrust so that aeroplane lifts in the air and it glides in the air. Now, since the aeroplane has its own body and structure and it is moving in the air, so this air will try to push the backward the aeroplane. Okay, that is called as drag. You cannot make drag zero, because the moment you have a structure, moment you have a surface area, there will be a friction. So this friction is no longer nothing but it is a drag. Okay, so clear on the forces of flight. Weight, which is because of the weight of the aircraft, it will try to pull it down, or the gravity which will affect. So to counter the weight, we have to generate the lift. How will generate the lift? By giving enough thrust. But you will give only thrust so that the aeroplane can glide in the air. If you have enough thrust, it will be always in a forward direction. It will glide in the air. The moment you reduce the thrust, what will happen? The gravity and drag will take over. Okay, that is where your aeroplane will try to descend, or it will try to be slower. Okay, so if you reduce your lift and your thrust, automatically your drag and weight will take over. Clear on the four forces of flight?
So if the
Yes.
drag and weight is more,
Hmm.
then it can come in a stall position.
Yes.
Okay.
See, if you see, for example, I stop the engine in between. Suppose आपके आप fly कर रहे हो, आपके दोनों engine बंद पड़ गए, तो क्या होगा? Thrust will be zero. But
Correct.
your aeroplane is aerodynamically designed. So at that point in time, it will not immediately go down. It will still glide. It will have at least 10 kilometers of range to glide. So the pilot can, call the ATC, ask for emergency landing. If there is no emergency place to land, he can safely land on an open area, or he can safely land on watery area also. Okay? But definitely the weight and drag will work. So he has to efficiently manage his angle of attack and glide as so far as possible, whatever he has time and whatever altitude he is flying. If he is flying at 30,000 feet, he will have a more glide option. If he is flying at 10,000 feet, he may have a less glide option. Okay, so depending upon again height and the aeroplane structure and all the things and the capability of a pilot, this is where actually the pilot comes in the picture. Okay, there, this is where his skills and everything comes into the picture, how he handle this kind of situation. These are things not cannot be handled by the autopilot or automation kind of thing. This is where human performance comes into the picture. Okay.
Okay.
Okay, now let's see what is the principles of light, how actually the lift is generated. So in physics, a fluid is a substance that continually deforms that is flows when external force is applied. Means what? The fluid like water or any liquid form. You say you are flowing. Like example, you see a tap in your kitchen. Okay, if you open the tap, the water will flow. You just hold a spoon. Okay, that curved surface of the spoon you see, the water will not stop there. It water will take the shape of that spoon. So this is nothing but it is called as Kondi effect. Similarly, air is nothing but it's a gas. Okay, gas. So it will follow the same principle of fluid or gas or plasma. It will deform around the surface. So when air is flowing around the wing, as it hits the leading edge, the air will flow above the wing and below the wing also. Okay, so that is what we called as Kondi effect. So not only above the surface but below the surface also the air will flow. Okay, so now let's see the forces. The lift is always perpendicular to the direction of the motion. That means what? Let me on the camera. So left is always in front. So what will happen? It will always be in perpendicular direction of the motion. So as aeroplane is flying this way, the lift will always tend to go up. Okay, so it will be always in a perpendicular motion. Why it is in always in perpendicular motion? Because difference in the pressure. Okay, we'll see what is difference in pressure in subsequent slides. Whereas weight is always downwards because of gravity. The earth is pulling it down. The weight is pulling it down. Whereas drag is always opposite to the direction of motion. So as it is moving this way, the drag will be always in opposite direction because the air molecules are hitting the surface of the aeroplane. That is because the friction and the difference in the pressure. That's why you might have seen even the cars are been aerodynamically designed. Your bridges are been designed aerodynamically. Even high towers, big buildings, the buildings which are like 25 towers, 30 towers, 40 towers. These huge buildings are always designed considering the aerodynamics because air will always impact the structure of those buildings or the car or the bridges or any bigger surface where the air will impact it. Okay, so friction and difference in pressure. So that is what we call it as drag with respect to the aeroplane. Okay. Now the most important part is Bernoulli principle. Now let's read out what is Bernoulli principle. The air is separated at the leading edge of the airfoil, rejoins at the trailing edge. Okay, so there is a air coming. Okay, it will go above the surface of the airfoil as well as below the surface of the airfoil. So the air will get separated at the leading edge. It will separated. It will some air will go from the above surface, some air will go from the below surface, and it will again join back at the trailing edge. Air has to move faster on the upper surface because it has to cover longer distance. Air flowing over the curved upper surface of the wing has more velocity because it has to cover the longer distance than the air flowing below the wing. Okay, so below the wing, the surface area is less compared to the upper surface area. This principle states that increase in the speed of the air occurs simultaneously with the decrease in the pressure. So as you see the air wing, whatever the air is flowing above the surface, it is moving at a very high speed. As it is moving at the high speed, there will be a low pressure created on the top, whereas on the below there will be a high pressure created because your air is flowing with a very slow speed compared to upper surface. So below surface there will be more pressure compared to upper surface. This pressure difference will cause upward lift. Okay, so decrease in air speed of airflow cause more pressure below the wing and produces the upward lift. Clear on this principle? So your air is flowing at a very high speed, so there will be a decrease in pressure. Similarly, the air flowing below the surface is slow. Okay, so there will be increase in pressure. Okay, so the more pressure is created below the wing, automatically the upward lift will be created below the wing. So your wing will try to raise up. Okay, that is how it will raise up. So same thing. If I am holding this hand like this out of my car window, nothing will happen to it. The moment I give little bit angle, my hand will tend to go up. Okay, so that is the lift which is created. But if I give more angle of attack, what happens? My hand will not rise up, it will go behind. So that is what I am increasing the drag. Okay, so I have to aerodynamically design the wing shape or the structure of the wing. Okay, similarly, you might have seen in Formula One car also, like there are wings type of structure behind and in front also. Like they direct the airflow because your Formula One car is moving on the road at very fast pace. Okay, so the air is also impacting on it. So to improve the performance, they have to aerodynamically design the Formula One cars. Same goes for your aeroplane also. Okay, so let's see now. Yeah, Priya.
So if I've got this correct, the reason why lift is being generated by the wind under the wing is because the wind that is moving above the wing is being displaced faster than the wind that is under the wing, and because of that, as we all know, that wind will move
Up.
up because of that.
So actually, it is a pressure which is created. Okay, it's
Yes,
not
because
moment. It
more
is
there's less pressure on top of the wing. Wind always
compared to
moves from
below.
high pressure to low pressure.
Yeah, compared to below. Okay,
Yeah,
so there is a low pressure on the top and there is a high pressure to below. Okay, so you see here the wind is coming from this direction, high velocity of air go because this is a larger area it has to cover and reach at the
right.
same point. Whereas the same air which is flowing below the wing, it has to cover a less amount of area, so it will be flowing at a low velocity, but it will generate a high pressure. Whereas there will be a low pressure. So this pressure difference will create a lift. Okay, so as your aeroplane is running on the runway and at a given point in time it will have a enough pressure difference which will create which will generate the lift. So जैसे हम लोग kite fly करते हैं, right? You might have seen when we are flying a kite or even car driving करते हो देखा रहेगा आपने that at given point in time when I am driving a car, at a normal speed, 40 speed, 50 speed, my car is very, very stable. Okay, 80k speed maybe, my car is very stable. But the moment I reach 100, my car starts shaking. Why it's shaking? Because there is a pressure difference is getting created. Okay, अगर हम कार को प्रॉपर एरोफॉइल स्ट्रक्चर जैसा बनाएंगे और इफ यू मेक इट आवर कार विल आल्सो फ्लाई एट एनी गिवन पॉइंट. कभी कभी हमारा कार कंट्रोल लूज करता है ना बिकॉज ऑफ दिस रीजन. Okay, all of a sudden our car trips, okay, left right or something like that as we tend to get the height, get the speed. Okay, that's why there is a speed limit given on the particular car. So the car have been also tested at what speed it can sustain it. नहीं तो क्या होगा आपका कार टॉपल भी हो सकता है. कार कैन बी टर्न अपसाइड डाउन ऑल्सो. So that is the reason why we have a speed limits on the car also, or there are structures which are being made, or there are purposely drag is being created in a car. Okay, like for example, आपका Volvo bus है, it can ride at very fast high speeds, but its shapes is not been designed aerodynamically. But if you see the design of a bullet train, how bullet train, because it is flying at a very high speed, it has to be created aerodynamically. Okay, so because of the weight and the pressure and all that things, it has to be designed in a such a way. If it goes beyond the capacity, even your bullet train can also fly or it can also get toppled also. So there is a limit or cap given for a particular speed. So they could have exceed the speed also. Okay, so they have to limit within the particular speed only at what it can be done. If they have to increase the speed, then they have to put control measures so that it doesn't topple or overcome the plot. Okay, so if you see here again, less pressure down, more pressure up. Wind is flowing below the wing, it is lower, whereas over the top of the wing, it is faster. So this is what it talks about the Bernoulli principle. Around this principle, using this principle only, Wright brothers designed their aeroplane. Okay, it's a very technologically at that point in time, 1903, they designed their aeroplane. There is a very good video on the YouTube. I will share you the link also that you see that aeroplane, how they design, how they overcome all the challenges, what could be there for or required for their aeroplane to fly, and they designed and they successfully made the first flight on 17th December 1903. Okay, using Bernoulli principle. Any questions so far on Bernoulli principle?
Nothing for me.
Sir, is Bernoulli a person?
Yeah, yeah, he was a scientist.
Okay, okay.
How we have Newton, we'll talk about Newton in next subsequent slide. Similarly, Bernoulli was a physicist. okay, who was working on the fluid mechanics. Okay, so as we talked about Newton's came into the picture. Newton's law of motions. I hope everybody knows what are Newton's law of motions. Okay, so Newton was a physicist or a scientist, I would say, great scientist. 90% of physics, what we learn, is all given by Newton. Okay, so Newton's law of motions, the first law states that if body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at a constant speed unless it is acted upon by the force. Suppose if I kick the ball, what happens? It will continually go into the motion, right? But eventually ball stops. Why does it stops? Because there is some force. The air molecules are affecting it. If the same ball, if I hit in a space, it will go endlessly. It will keep on going until it has been stopped or it been obstructed by something. Because there is nothing which can obstruct its motion. That's why you see when we send a spacecraft like our Voyager 1 or Voyager 2, okay, when it was sent in 1977 or that period of time, it is still going on in the space without any fuel or any requirement. Okay, it is endlessly crossing the boundaries. Okay, now right now I think it is in interstellar space, both the aircraft. So that is what is the first law of motion. If the body is at rest, it will be always at rest. Body in motion will always be in motion until unless it is been acted by an external force. Okay, that is Newton's first law of motion. Newton's second law says that as the body is in motion, it will keep on in motion. If you want to change the direction or maybe wanted to increase the acceleration, you have to apply the force. How much force you need to apply on that body? You need to, there is a formula given by Newton which says force is mass into acceleration. So whatever acceleration you need to give to that particular body, that mass and that acceleration you have to give, that force will be create more force of acceleration. For more force, more acceleration would be required. So if you need, like for example, if there is a train, coach is going on a track. Okay, if I need to give up more power or more faster, what I need to do? I need to connect the engine and give more acceleration to the coach. Then only it will move faster. Okay. So the momentum of a body is equal to both magnitude and direction of the force imposed on it. Okay, that is what it talks about the Newton's second law. Now Newton's third law is very important with respect to the drones. Okay, because your drone fly with help of Bernoulli principle and Newton's third law. Not only Bernoulli principle is effective on the drones. Okay, and when I'm saying drones means rotorcraft I'm talking about. Okay, the rotorcraft means wherever there is a propellers. Okay, which are being used to fly the drones. Okay, now what happens? Now first let's understand the Newton's third law. Newton's third law states when two bodies interact, they apply force on one another that is equal in magnitude and opposite in direction. For example, we have taken example of a rocket. Now rocket is there which is stationary, which is attached to the launch pad. What happens? Does it move? No, it doesn't move. It is fixed to the launch pad. But the moment we ignite the rocket, what happens? There is a reaction happening in the rocket. It ejects the high powered gas. Now what does this gas does? Gas will try to push the earth below. But can it push the earth below? No, because that force is not that powerful to push the earth. So what will happen? Since it is not able to push the earth down, what will happen? It will affect the rocket itself. The rocket will try to race. Okay, so it will race on the launch pad and it will climb in the space or in the sky. Initially, it will go into the sky, and eventually, if you have enough thrust or enough force generated by the rocket engines, it will escape the Earth's gravity and go into the space. So same thing is applicable to your drone also. So when you start your drone, your rotors are moving. Okay, rotors will start moving slowly initially, and you will give a power. So your rotors will start moving fast. So what is trying to do? The air from the top will try to push it down on the ground. So all your four propellers, I'm taking example of a quadcopter. So all four motors will give the thrust equal power to the down. It will start pushing the air down and it will try to push the earth. But can drone push the earth down? No, because it's a small object compared to the earth. So in that, what will happen? Newton's third law will come into the picture. Your drone will start rising up. Okay, so you will give throttle. You will give throttle, enough throttle so that your drone is safely up in the air. Okay, the beauty of the drone is that as it climbs in the air, it can stand at a particular movement or a particular location or a particular latitude, longitude, what we call, or a particular altitude also, what we call. Okay, so that is what we call it as loitering. Okay, or hovering. Hovering effect is possible in quadcopter or in drones. Okay, this is not possible in aeroplane. Your aeroplane has to be always in a constant motion because it is using aerodynamic principles, whereas drone is using Newton's third law of motion. Only Bernoulli principle is applicable to the design of the propeller. Okay, if you see the shape of the propellers are designed using Bernoulli principle. So the propeller will also have a leading edge as well as a trailing edge on the blades. Okay, so you need to identify the leading edge and the trailing edge. Based on that identification, you can define the type of a propeller. There are two types of propeller. One is called as clockwise propeller. There is another propeller which is called as counterclockwise propeller. Okay, so there are two types of propeller. So looking at the propeller, you should able to identify the type of propeller. So any questions on the Newton's third law and how it helps for drone to fly in the air? So it is not only the Bernoulli principle which is useful for drone flying, it is also the Newton third law which comes into the picture when you are flying the drones. Any questions so far? No? Okay, so if you see, as I am flying the aeroplane, the center of lift is the average of the lift force through which all the lift is considerable to act. It's same as a center of pressure. So there will be a center of lift, okay, and there is something called center of gravity. Center of gravity is with respect to the weight. Okay, the more we weight add to the aeroplane, the center of gravity will change. Like if you have a fulcrum in your hand, okay, like this, and you try to balance it, okay, so you have to balance, right? So wherever I try to balance it, that is called as center of gravity. But center of lift can change. Okay, ideal position, your center of lift and center of gravity has to be at the same point in an ideal condition. But for having a lift, your center of gravity always has to be little bit ahead of your center of lift. So normally what we call that point is called as nose heavy. So now you will see the design of aeroplane. If you see here design of aeroplane, your front part is always bigger, whereas your back part is less or smaller. Okay, so you are heavy in the front side compared to the back side. So you will always say your aeroplanes are always designed as nose heavy. Okay, so nose heavy means it will be always nose heavy, which will create a proper lift. So your center of gravity always has to be little bit ahead of center of lift. Okay, so that is always how the design of the aeroplane is being made. That's why you see on the tail section there is a curved section here. They make it smaller. Even the weight, what is been whenever there's the loading is happening in the aeroplane, the loader will always load the luggage or everything in front of the aeroplane. Okay, so they will balance it out such a way that it has been balanced and the center of gravity is always little bit ahead of center of lift. So your center of gravity will be always ahead of center of lift. So your aeroplane is always heavier in the front. The point at which aircraft would balance where it possible to suspend it at that point. That is called center of gravity. Yes, Nishant.
So why the center of gravity has to be ahead of the center of lift? Why not in alignment?
So in LC, it is all efficiency. First of all, is efficiency and the to have a better angle of attack. Okay, if your aeroplane is heavier at the backside, what will happen? It will go like this. Okay, so drag will happen. So to balance out, you need to balance it. Like when you are riding a bicycle or a bike, what are you trying? You are balancing, right? You are balancing. You know which side you will fall down. So accordingly, you will manage or control. Similarly, when aeroplane is being flown, Okay, now it has been flown by autopilot, but in olden times when there was no autopilot was there, it is the skill of a pilot. So pilot is feeling how the aeroplane is flying. He knows how aeroplane is flying, what control he need to give. He knows how it is. So when he is acting, he need to have little bit heavier in the front side. अगर heavy नहीं होगा तो क्या आएगा, वो topple हो जाएगा, ऐसे हो जाएगा. Okay, so you need to have a more weight in the front so you can manage it effectively. It's you need to have a efficiency in flying. Okay, so by see this front structure, the entire fuselage you can't do any change. You can't change. What is that you can change? Only the structure and the angle of attack. Okay, and power you can generate by the thrust. Okay, imagine you do not, you are flying a glider. In glider you are not having a thrust. How you will manage? तो ग्लाइडर में देखो आप क्या करते हो, जब ग्लाइड करते हैं तो पीपल नॉर्मली टेंड टू गो फॉरवर्ड, राइट. देयर इज ऑलवेज अ वेट इन अ फॉरवर्ड, so you can control it. अगर आप पीछे होगा तो क्या होगा, वो पीछे के साइड चला जाएगा. ओके, यू विल टॉपल डाउन. So you no longer your glider will be in a flight condition, but you will fall down like a dead rock. Okay, so you normally
So, but then what in the case of rear-engined aircrafts?
see, the engine is only giving thrust. It is not adding any weight. Engine, wherever you are placing the engine, it is only generating thrust or a forward motion. Your lift is being created by the difference, Bernoulli principle. Engine is not direct. You see, by just putting an engine will not see. For example, if I attach the engine to the car, imagine I put the engine to the car. Will my car fly? Because there is no aerodynamic surface. It will not fly. It will just move forward. वो रनवे पे भागते ही रहेगा endlessly, but it will not generate the lift. Okay, so engine is only give the thrust or it will give only forward motion. Now when it is on the runway, it is giving the forward motion, but the moment you generated the lift, aerodynamically you are in the air, you are suspended, but to maintain that your engine is giving thrust. The moment you stop the engine, what happens? Automatically the drag and the weight will take over. But since your wings are aerodynamically designed, you will glide certain point. The aeroplane can be managed by the pilot to fly certain distance. अगर इंजन वापस स्टार्ट कर पाए, you can again gain, or you can control it aerodynamically. You can safely glide to the safe point. Okay, all that thing you can possibly happen. Okay, there is a one beautiful uh, episode about aircraft where there was aircraft flying from Boeing aircraft flying from UK to Sydney. Okay, and it was flying over Indonesia, and all of a sudden because of that volcanic ash, all the four engines stopped working. So you are no longer running with engines. Okay, you are flying without engines, no engines. And even because of that volcanic ash, the wind, sorry, the what is that called, glass panes were also were obstructed. So pilot was no longer able to see what is happening outside of the aeroplane also. So he was flying blind. Okay, but he safely landed the aeroplane using instrument and the instructions from the ATC. Okay, so that's a very beautiful episode. You should see that on YouTube. You will understand what is the airman craft shift of pilot skills is there. Okay, when the pilot comes into the picture.
So, what is the name of the episode?
I think it is called Flying Blind. Flying Blind. I will share you the link. I have the link. Okay. So aerodynamics is the study of how gases interact with the moving bodies. Engineers can apply the principles of aerodynamics to design of many different things, as I told earlier, including buildings, bridges, or even cars. Okay, the primarily concerns of aerodynamics are aircraft and automobile. So you see the shape of your car. बोनेट आगे का छोटा रहता है, लेकिन पीछे जो डिक्की रहता है वो बड़ा रहता है, राइट. बिगर शेप रहता है. यू कैन हैव लाइक सी द शेप ऑफ इनोवा कार. Okay, Innova car is very aerodynamically designed. Okay, so the automobiles are being designed aerodynamically, but somewhere they cannot be designed completely aerodynamically because they need to add a drag. नहीं तो एरोप्लेन, नहीं तो आपका कार हवा में उड़ने लग जाएगा. Okay, because people tend to drive car very fast, so you need to make sure that it doesn't flies. It drives on a road itself. It doesn't, road को छोड़ के नहीं fly होना, drive होना चाहिए कार को. So that's why they are not 100% aerodynamically designed. Aerodynamics comes into the play in the study of flight and the science of building and operating an aircraft, which is called as aeronautics. Okay, so the aeronautics is the study about the flight and the science of building and operating the aircraft. So that's why we say aeronautics engineering, or so aeronautic engineering is basically study of building the aircrafts or operating the aircrafts. Yeah, Nishan.
Sir, I had an offbeat question actually.
Yeah, tell me.
So, uh, in terms of the vehicles, the cars,
Hmm.
can a SUV
Hmm.
be designed aerodynamically?
Yes.
Are there any examples of an SUV which is designed aerodynamically?
So any car which you see, they are all aerodynamically designed. See, but they do not design 100% aerodynamically. अगर वो
Okay.
पूरा करेंगे तो क्या होगा, वो आपका टॉपल हो सकता है कार. So they have to have drag. तो इसके लिए आप देखो, the structure is designed so that it can swiftly move through the air, but it cannot be 100 because there is no structure. If you attach a wing to your SUV, your car will also fly. It will take off. ओके, आपका कार में और एरोप्लेन में क्या डिफरेंस है? कार में विंग नहीं है, बट इफ यू पुट अ विंग ऑन द टॉप, लाइक इनोवा के ऊपर आप विंग लगा दो एरोप्लेन का जैसा, इवन योर इनोवा विल फ्लाई. एटलीस्ट इट विल टेक सम फ्लाइट. वो 100% फ्लाई नहीं करेगा बिकॉज देयर इज नो इंजन टू गिव पावर, राइट? हवा में जाने के बाद क्या होगा? व्हाई इट इज रोटेटिंग? बिकॉज वो व्हाट इज कॉल्ड टायर, हवा में जब व्हेन इट ग्लाइड्स, it will glide for certain point in time, but there is no power or there will be no thrust. Thrust कहाँ से मिल रहा था उसको? टायर के वजह से, because it was running on the road. But moment it is in the air, it will not have the speed. जितना speed उसको moment of inertia मिला उतना, but at given some point in time it will slow down. आपका इनोवा नीचे आ जाएगा, करेक्ट? So उसको क्या चाहिए? उसको इंजन लगाना पड़ेगा आपको. The engine which will give a forward thrust. Okay, I hope you understood what I was telling you. So
Yes,
आपका
yes.
कार भी is capable of flying only because it doesn't have a surface. अगर आप वो लगाओगे तो वो भी होगा, but वो certain point of glide करेगा और नीचे गिर जाएगा. Okay, to make it keep it floating, it needs a thrust engine, jet engine, या even turbo prop भी आप लगाओगे तो हो जाएगा आपका. It's the same principle. आपने देखा रहेगा ना, लाइक जो स्मॉलर एयरक्राफ्ट, टर्बो प्रॉप जो इंजन एरोप्लेन होते हैं, वो क्या होता है? इट्स लाइक अ कार ओनली, स्मॉल कार, और इवन स्मॉल चार्टर एरोप्लेन. व्हाट इज चार्टर एरोप्लेन? दे आर लाइक एरो कार ओनली, नथिंग डिफरेंस इन इट. ओनली दे आर मोर efficiently aerodynamically designed. That's why they are able to fly and they have an engine which can give the thrust.
Right, sir.
Okay, now let's see. Now as you have taken the topic, this will give you more clarity. Okay, this slide will give you a clarity. There is something called as a control surface. So aircraft control surface, there are primary control surfaces and there are secondary control surfaces. So on wings, on the outer side, there is something called ailerons. Okay, so ailerons will actually make your aeroplane to roll. Okay, roll means like aeroplane is moving. As you give the control, your aeroplane will roll. This is called roll motions. Okay, just a minute. I am getting a phone. Okay, sorry, there was a call from a student. Okay, so control surface aileron is on the outer side of the wings, which will control your roll motion. So now we'll be talking about these things. Okay, in drone also we'll be talk about the roll motion. So this is your forward motion, and when I say roll right, it will be like this. When I say roll left, it is like this. Okay, So this is being done by ailerons on the wings. Okay, the outer control surface is called ailerons on the wings, which will give you roll motions. Okay, so it will bang on the right side or it on the left side. Okay, whereas on the horizontal stabilizer, on the tail section, there are two stabilizers. One is vertical stabilizer and there is something called horizontal stabilizer. So this is your horizontal stabilizer. Okay, there you will have a control surface called elevators. So elevators is nothing but as you control the elevator, your pitch up or pitch down. Okay, you will able to pitch up and pitch down by using elevators. Okay, whereas the horizontal stabilizer, okay, sorry, vertical stabilizer, the wing changer or tail, it has a control structure called radar. So radar will do what? As you turn the radar, your aeroplane or the drone will change its direction. Okay, it will change the direction. So it will turn in right direction or it will turn in a left direction. So radar will change the direction, elevator will give the pitch. Okay, either you have to, like for example, ATC calls the pilot and say, okay, you need to change your altitude from 10,000 feet to 15,000 feet. So he will use elevator to pitch up. So it will pitch up and it will go to 10,000 feet. Or ATC calls and say, okay, you are now at 20,000 feet, you are going to reach Delhi airport, so you can descend to 15,000 feet. So he will do pitch down. So he will come down. Okay, so by changing the elevator angle of elevators, he will able to bring up and down. So that is pitch and pitch motion, up and down. Okay, whereas there are other controls like spoilers, flaps, slats. Okay, these are additional controls. So when I say primary controls are ailerons, elevators, and rudders. Any aeroplane which is okay, which is flying will always have these three primary control surface. Without these three primary control surface, you cannot control your aeroplane. Okay, so you need to have a aileron, you need to have an elevator, you need to have rudder in your aeroplane. Okay, with this only three you will able to control your aeroplane motions. There are additional secondary controls which are called spoilers, flaps, slats, or there are other tertiary also are there like smaller. These are only available in a bigger aeroplanes. Like for example, if I give an example of Cessna will only have ailerons, elevators, and rudders. It will not have a slats, it will not have a flaps, it will not have a spoilers. It will only have a primary control surfaces. But if you see bigger aeroplanes like Boeing, Airbus, which is big in shape, they will have all the secondary, tertiary controls also to give a better control on the aeroplane. Okay. Now, for example, where is spoilers are being used? Spoilers are used when you land. Okay, you want to increase the drag, so you will increase the spoiler. So it will drag. It will create more drag on the wing, so that your aeroplane will slow down on the runway. Okay, slats and flaps, they actually increase the surface of your wing, so to generate more lift. So these are being used during the takeoff your flight. When your flight is being take off, it is gliding in there, then probably your slats and flaps can go inside. Okay, but to increase the better lift and all the things, that time the slats and flaps are used. So any questions on the control surface? Only remember, on the wing you have ailerons, on a horizontal stabilizer you have elevators, on your vertical stabilizer you have radar. Your aileron will control your roll motion, your elevator will control your pitch motion, your radar will control yaw motion. Yaw motion means direction motion. Any questions?
So
Any
if you can
questions?
repeat about slats, spoilers, and flaps one more time. And what are
Okay, so slat
trimmable horizontal stabilizers, sir?
trimmable means you can adjust.
Adjust. Okay.
Adjust. Okay, so sometimes what happens, no, like if you see here radar. Okay, now normally in older planes, in a radar, there will be only one control structure. But in a bigger aeroplanes, you will see there are multiple sections. Okay, so you can adjust. You not only one single surface is changing, but you can control by two radars. Okay, there will be a split in the radars, so you can accordingly control your motions. How precisely you want to turn, how accurately you want to turn. So smaller aeroplanes will not have that flexibility, whereas the bigger aeroplane will have this additional features, trims. Okay, trim tabs what we call. Okay, so you can minutely also change. Even some radar will have a bigger surface. Within the radar also there will be a smaller structure also which can change in opposite direction. So that is what is a secondary surface or secondary controls, what we call trimmable.
Okay.
Okay, whereas spoilers is basically nothing but like if you have a wing like this, okay, ये wing है, आपका shape ऐसा है wing का. If I put something here opposite, like it normally it is like this, okay, like this. All of a sudden I make this. This is spoiler. So that means what? The wind is not smoothly flowing above the wing. It will try to go up. Okay, so it is actually creating a hindrance for a flight. So these spoilers are, that's why it is called spoiler. Okay, it is spoiling the flight. Okay, so this is applicable when you land. You will see the spoilers coming up. If you have taken a seat near the wing, okay, you will see these spoilers getting activated when you land on the ground. The moment you land on the ground, the spoiler will be up. Okay, because the
Yes,
pilot
yes.
wants to drag,
Accelerated.
increase the drag in the aeroplane so that it stops very quickly. Aeroplane stops very quickly. There is another way, like in a jets, military aircraft. How do you increase the drag? By attaching the parachute. पीछे parachute खुल जाता है. Okay, so it basically creates a more drag, and that tends to slow down your aeroplane on the runway. Okay.
Yes.
So now further more explanation, like as I said, aileron is roll, longitudinal axis of rotation, type of stability is lateral. Now if you see here, okay, so elevator is with respect to the pitch, your roll is with respect to the wings, and your pitch is with respect to your elevators, and your yaw motion is with respect to the vertical, is with help of radar. Okay, so remember radar. So you first sorry, remember these three words. Aileron is with roll. Okay, it affects longitudinally. This is longitudinally. Okay, sorry, this is longitudinally. So longitudinally, what happens? It will go longitudinally. Okay, this is longitudinal axis, but it will affect this motion. Okay, so this is rolling. Okay, whereas elevator or stabilator, what we call also. It is a pitch. That means what you are going straight. As you change your elevator, what will happen? It will pitch up or pitch down. Whereas rudder is backside, okay, the tail, okay, vertical section like this, vertical section like this. The moment you change your rudder direction, what will happen? Your drone or your aeroplane will tend to change the direction. Okay, so it is with directional. You see the type of stability is directional. So yaw motion. Okay, so when we are having a drone in hand, now this is this all we are talking with respect to the aeroplane. Now we need to understand how these are applicable for our rotorcraft, because we are training under rotorcraft category. Okay, so we are talking about rotorcraft. How these motions will be in case of rotorcraft or in drones. Okay, we'll see in subsequent slide. Okay, so takeoff. It is a phase of a flight in which aircraft goes through a transition from moving along the ground to flying in air, usually starting on a runway. For balloons and helicopters of some specialized fixed wing aircraft, no runway is needed. It is basically fixed wing means basically we are talking about hybrid aircrafts, okay, where no runway is needed. So it will take vertically. Okay, like your balloon also will take off vertically, your helicopter will also take off vertically. So there is no required for takeoff. But that is also, that action is also called as takeoff. हम बोलते हैं ना helicopter ने take off ले लिया, balloon ने take off कर लिया, even fixed wing we say we take off, or drone also we will say take off. Okay, so I will say okay now Nishant, you please take off your drone. So now you will give a throttle and you will take off the drone up in the sky. Flight. Now what is flight? Once you are in the air, okay, your fixed wing aeroplane will always move in a forward direction. So it is the force by which the object moves through an atmosphere without contact with the surface. So you are away from the ground, you are above the surface. This is achieved by generating aerodynamics lift associated with the propulsive thrust. So it is not only the aerodynamic lift but associated with the propulsive thrust. Means what? Your engines are running, it is giving thrust, forward thrust. Then only your aeroplane will move into the air. Similarly, if your drone has to move upward direction, the propulsive thrust has to go. The propellers has to move in a direction. Okay, if it doesn't move, what will happen? Your drone will fall down. The moment your propeller stops running, your drone will fall down like a rock. Okay, it's very difficult. Even one single propeller भी अगर fail होता है या one single propeller या one single motor also stops, your drone will become unstable and it will fall down. Okay, so in quadcopter even one single motor fail हो जाती है, your drone is at risk. Okay, that's why your pre-tests are very important before taking off the drone. Okay, whereas landing is the last part of flight where airborne aircraft returns to the ground. When the flying object returns to the ground, the process may also called as touchdown. So aeroplane normally will tend to descend and it will land safely on the ground. Your drone will you will reduce the throttle and safely land on the ground. So I last time there was one student who asked me a question like how like normally aeroplane is the descent mode, right? It is descending and it is slowing down. Whereas how does the drone lands? Okay, so what we are trying to do is we are reducing the throttle. When we are reducing the throttle means what? We are actually reducing the speed of the propeller. So what happens when we reduce the speed of the propeller? No longer it is counteracting the gravity. So gravity is overpowering the throttle. So your trend, because of the weight of the drone, it will start slowly coming down. Okay. So you have to manage that throttle so efficiently that you are doing a smooth landing or smooth takedown or touchdown, what we call it. Okay. So that is your landing. So clear on this option, takeoff, flight, and landing. Any questions on this?
No, sir.
Okay, so let's see now the last slide, that is maneuver, turns, and circuit patterns. So what is maneuvers? Okay, so when you are in air, like for example, first take a like example of aeroplane. So when I take off from Mumbai airport, what I will do is I will have a flight plan defined. My pilot, the pilot who is flying the aeroplane, he will always have a flight plan. He knows on what area and he has to fly the aeroplane on the flight plan only. He cannot fly the aeroplane wherever he wish as he is in the air. Okay, he has to fly the aeroplane on a approved flight plan. So as you take off, you will take off and you will start flying your aeroplane in a steady flight. Okay, that is a level flight what we call. So moment you climb in the air, within a moment or some minutes, your aeroplane will be somewhere around 10,000 or 15,000 or 20,000 altitude. Okay, and then it will cruising till its destination, maybe 20 kilometers ahead of its destination. It will be cruising at that altitude because that is the altitude what is being given by ATC to him, and he has to continue fly on that level until unless there is any issue while flying. So that we'll see what kind of issues can come when we are flying. That we'll see in weather and meteorology. Lot of time we face problems when due to weather. Okay, so we'll see in tomorrow's topic in weather and meteorology what problems can occur and what corrections we need to do. Okay, so if we have to do any turns or climb, so lot depends upon the ATC instructions, or else I have to continuously fly my aeroplane in a approved flight plan only. So my, for example, if there is any issue like turbulence is there, I may have to take a turn. That means I may have to bank on the right side or the left side, or may I have to turn completely yaw. Okay, so I may have to turn 90 degrees. So when I have to fly 90-degree, I will do yaw. Okay, so I will use my rudder to do yaw. Okay, when I have to roll or bank, then I will use ailerons. Okay, so ailerons will bank my aeroplane little bit on the left side or sorry on the right side or on the left side. Okay, so that is turns. Climb, like for example my ATC tells me that okay you have to climb, there is a incoming flight in front of you and you have to climb to from 15,000 to 20,000 feet. So that is a climb. So you will have to climb. So what will you use? Elevators. So elevator will change and you will pitch up. So you will climb. Or you have coming approach Delhi airport. You are at class ATC to give you the landing approval. So you will start once you ATC gives you the approval, you will start descending. So that is your descent. Okay, so basic four fundamentals of flight maneuvers are straight and level flight, where you are continuously maintaining your altitude. Sometimes you may have to turns left and right, okay, or you have to climb up or climb down. So similarly in drone, when you are flying a drone, I will normally instruct you to fly a drone high up in the air, somewhere around 8 feet. Okay, 8 to 10 feet of height, comfortable for you to view because you are flying your drone under VLOS condition, but visual line of sight. So I will not ask you to fly 100 feet above. Okay, anyway, our drone will not able to fly 100 feet high because it has a limit also of flying high also. How high it can fly. Okay, so I will tell you to fly your drone around 8 to 10 feet in height. That altitude you need to maintain. Then I will tell you roll right. For example, when I say roll right, means you have to roll right. When I say roll left, you have to roll left. If I say roll your right, you have to turn your drone yours in right direction. That is 90 degree you have to turn. If I say your left, you have to turn your drone in a left direction. You have to turn 90 degrees. I will tell you pitch forward. Now here there is a difference. Okay, understand from the aeroplane and the drone. Aeroplane pitch is height. You are changing the height. Here height and pitch is two different things in drone. Okay, in quadcopter. When I say pitch forward means you are moving forward direction because your drone is stable, is in hovering condition. It is locked to one particular location. When I say pitch forward means you are moving forward. When I say pitch back, you are moving back. When I say throttle up, normally I will never tell you to throttle up, okay, or throttle down. Normally you will be always operating your drone at a particular fixed altitude. You will, when I say throttle up, then only you will go up. So from 10 feet, you may go to 12 feet, or I will say throttle down. So you may go from 10 feet to 8 feet. So that is your motion in your drones. Okay, so climb or descent is throttle up and throttle down, whereas pitch in drone is forward and backward motion. In drone only it is possible to move forward and back. In aeroplane you cannot move back. Move back करना है तो क्या करना पड़ेगा? पूरा एक चक्कर लगा के आना पड़ेगा to come position in the back side. Okay, so if you missed your descent properly, what you have to do is you have to climb, you have to take a circle and come back and align your aeroplane for touchdown. Okay, whereas in drone you can always control by up and down, forward and backward motion, left and right. All directions are possible in drones. Okay, which is not possible in a fixed wing. Fixed wing is always in a forward motion or forward direction. Okay, so any questions so far? So this is again a circuit pattern. Normally this kind of circuit pattern is shown for only reference purpose, or this is only done during the training purpose. Normally you will not fly a aeroplane on a same runway and you land on the same runway. It will be only done during small general aviation airfield or military airbase. Like for example, in military airbase where they do trainings, okay, or they do sortie. That point in time only they will take off and they will fly on the same runway. Okay, or even when our pilots, like we are training our pilots on Dule Air Force or Mumbai Aerodrome, that location only you will actually fly your aeroplane and take fly and again touch down on the same. So this because you are doing a short circuit patterns over there. You are learning, you are flying, you are learning to fly your aeroplane. That's why you will always take off and, but normally this in a real commercial or civil airplane, what will happen? The takeoff will happen at the Mumbai airport, whereas your landing can happen on your destination airport. Your destination could be Surat, destination could be Ahmedabad, your destination could be Jaipur, or your destination can be Delhi also, or then in that case it could be Kolkata or Chennai also, or maybe Hyderabad also, wherever is your destination. So your takeoff is from Mumbai, your destination can be anywhere across globe, depending upon your flight plan. Okay, clear? Any questions?
Yes.
Yeah. Give me a minute. I need to take a call because okay. Any questions on circuit pattern? I hope now it is clear on the motions. with respect to the fixed wing and with respect to the drones. Again, this will be repeating in our respective topics of fixed wing and rotorcraft also, and even during the hybrid also. So this will keep on repeating. Okay, even during our flying also, practically we'll be seeing all these things happening. Okay, so don't worry about it. Even you not understood or you are getting confused, you feel free to ask me, not a problem. But over the period of time, all things by the end of your fifth day, I am sure that all your doubts will be cleared. You will be more proficient than what you are today. That is my assurance. Yes, we will be taking a coffee break now. Okay, so I think just a minute, just hold on. Okay, so anyway, we have completed the topic over here. Let's have a coffee break of 10 minutes and come back by 4:50, right?
Okay.